flip video about solutions and something called molarity. So let's first start talking about what a solution is. A solution is when you take something called a solute and you dissolve it in a solvent. So taking something like a salt would be an example of a solute and dissolving it in something like water. Water is our universal solvent. Majority of our things are dissolved in water. So let's break that down and make sure you have these two words and their definitions. Again, a solution is made up of a solute. It's what's being dissolved, so here I have some salt particles, and plus a solvent. It's what does the dissolving. So water is our number one solvent we use. Anything can be a solvent, it's just water is a very popular solvent. It does the dissolving. So if I was to take a look here at my beaker full of water, right? My water is the solvent. Here's my water. It's my solvent. And then if I was to take my salt and drop them into my beaker, my salt is my solute. Together, this makes a solution. Okay? Well, now that we know what a solution is, what's next important is to understand what the word concentration means. How concentrated is my solution? So again, if this is my solution, how concentrated is the solution? Concentration is how much solute I have dissolved in my overall solution. How much solute makes up this entire solution. Remember, this whole thing is a solution. That's what concentration is. So how can I measure how much solute is in my overall solution? That's what molarity is. So molarity gives us a number. It gives us a measurement of how concentrated a solution is. So instead of saying this is not very concentrated, I want a number. Or this is very concentrated. Can you give me a mathematical number? That's what molarity is. So there's an equation that we use to measure concentration. Again, it involves molarity. Molarity uses capital M, not lowercase m. Please make sure you get that right. Capital M stands for molarity. So if you take your moles of solute, so my moles of solute divided by my liters of total solution used, I can calculate concentration. This equation is used to calculate concentration. It's how much solute is in my solution. My units must be in moles, and my solution has to be in liters. So it's moles over liters. And if you don't have moles and liters, you need to convert. So let's take a look at some examples. Here we go, our first example. What's the concentration of a solution that contains 4.0 moles of NaCl? Okay, so right away I can tell that this is my solute in 2.0 liters of a solution. Okay, I bring back my equation here. Moles of solute, liters of a solution. Okay, so all I have to do then is take these numbers and divide them by each other. 4.0 moles of solute in 2.0 liters of my solution. Okay, good. Do the math here. 2 sig figs here, 2 sig figs here. So capital M is equal to, hopefully you said 2.0, and the unit is right here, moles over liters. And I don't have to label anything else since it's kind of a chunky unit. Or I could also write this as big M is equal to 2.0 big M. So I can use big M as a unit or moles over liters. These are the same unit. Okay, this was an easy one. What if my units weren't already prepared for me? Meaning, what if I had other units? Remember, I have to make sure that I always use moles over liters. So let's take a look at this example. What's the concentration of a solution that contains 1.0 grams of NaCl in 5 liters of a solution? Okay, remember, I needed moles of the solute, right? But I got grams. So can I convert grams to moles? Hopefully you said yes. And 5 liters of a solution, that still looks good. Okay, so what's the conversion? Well, hopefully you remember in this chapter, 1.0 grams of NaCl can be converted to 1 mole. Remember, 1 mole is equal to the mass in grams from the periodic table. So I look up the periodic table and I find the mass of sodium, right? And I get, look at my sticker, and I get 22.99 grams. And I look up the mass of chlorine and I get 35.45 grams. Add them all up together, go to 2 decimal places, and hopefully you're following along in a calculator. Should get that. Okay? Grams of NaCl, moles of NaCl. When all is said and done, get your final answer. So whatever that may be, 1 divided by 58.44. At this point, I'm going to rely on you. Right? Whatever your answer is, moles of NaCl. Okay, make sure it's a decimal. And now I have my moles of solute, whatever that number is. So take a second and calculate this. Okay, so that's just the first step. So we now plug in that value, capital M is equal to whatever we just got on that step, moles of NaCl. Don't forget, you're doing that calculation. Put that number in here. And then my liters of solution, let's go back to the problem, are right there, 5.0 liters of solution. Again, divide these two numbers. Don't forget sig figs. I've got 2 sig figs here. And in my last problem, I also had 2 sig figs. So my final answer, divide these two and get an answer in 2 sig figs. And your unit can be one of the following, moles over liters or capital M, like we just discussed. Both units are appropriate. Okay? Let's really quickly look at another problem. Getting a little bit more complicated, a little bit more algebra. How many moles of solute? Ooh, okay. If we remember, this is our equation, moles of solute over liters of solution. And this problem right away tells me how many moles of solute are needed. I'm solving for this. So let's make that my x. I'm going to solve for x. Think about this as math class. The best way to do this algebra is, if this is a fraction, make this a fraction and cross multiply. So 1 times x is x, and m times L. Now all I have to do is plug in the rest of my information. So here's my x is equal to my molarity. So let's see here. How many moles of a solute are needed to make a 3.0 molarity solution? We also call this a 3.0 molar solution. That goes, capital M goes in capital M. Put this here. Times, and I'm looking for a liter in a solution with a volume of 5.0 liters. That goes there. Okay? When I solve for this, I get 5 times 3 is 15. 2 sig figs, 2 sig figs, 2 sig figs. I have, let's just go back and see. I was solving for x. X is moles. Moles of my solute. There's my answer. A little bit trickier, so you might want to go back and rewind the video and see how to do that math. That's the end of the video.